Welcome everyone to the very first chapter of your Java placement course. In this chapter, we will be diving into the theoretical part of Java as per our syllabus, and we will be covering the most important topics from where the interviewer will ask questions generally on the face-to-face interview. Okay, so generally this theoretical part many students will leave by thinking that what is the use of this, but there are a lot of topics from where the interviewers will ask the questions. The very first topic is about Java platform independence. Then you have how the Java code executes, why is Java both compiled and interpreted, what is the exact difference between JDK, JRE, JVM, and you will also get questions on explaining this particular part. We all write this particular part in the exam or in the code: public, static, void, main, string, args. But what is the exact meaning of each and every word? You will be asked to explain these things. Okay, so that is why this lecture is of utmost importance, given the fact that there are online assessments and then there is also a face-to-face interview. So let's get going. The very first point here that I would like to make is Java is a high level language. What do we mean by high level language? High level language means you are writing it in English, which is human readable, which is understood by the humans. That is why it is called a high level language. Then what is another language? That is ML, that is machine level language, which is understood by the compiler, the computer, everything. And we know that they understand nothing but binary. Binary means 0 and 1. 0 means low voltage, 1 means high voltage. Because in the end, computer is nothing but a electrical component. Okay, if it has to pass 0, it will pass low voltage. If it has to pass 1, it will pass high voltage. Great, cool. And then Java is OOP language, object oriented programming language. Okay, so this theoretical part is both for ICSE as well college students. Okay, so you can find it in your course as well. Okay, cool. So the very first top point is Java is a high level language. It is OOP language, object oriented programming language. What is the other language? That is procedure oriented programming language. Okay, so no one is going to ask you too much deep on this. Okay, but we should just know the features of OOP, and the features of OOP will be obviously discussed in detail with along programs like inheritance, polymorphism, etc. Right, here is just one fact. It was founded when it is now owned by Oracle. Okay, and then you have James Gosling. Okay, so for Java we have one more instructor. Maybe he might be joining with us. He actually works at Oracle only. Okay, so let's go forward. And now we are going to understand the features of Java. So when you talk about the features of Java, this is not a school exam where you will be asked what is the features of Java, right? In the school level exam or board level exam, they might ask you what is the features of Java, and you will write it is platform independent, secure, robust, portable, case sensitive, right? But in interviews, in college interviews, in placement interviews, you are asked why. You are asked the heavy question why. Why is Java platform independent? Why is Java secure? Why is Java robust? Do we get it? So here is some use cases of Java. So this you can just blindly read it, like it is used in web apps, Android, bank systems, enterprise setting. But let us come to the most important point. Why is Java platform independent? Okay. See, you wrote, you know that you write your code in high level language, right? Java is a high level language. So you wrote your code in English, right? This code actually has to be converted into your machine language. Then only the compiler, you will understand, right? But Java does not directly convert this into machine language. Okay, what it does, once you wrote your code in high level language, it converts it into an intermediate bytecode language, intermediate bytecode. This bytecode is then ran by the JVM. JVM is what? Java virtual machine. Java virtual machine. So it is not a physical machine. Okay, so I will tell you one thing. You know, in the world there are around, like, we can broadly say that there are three operating systems. Okay, Windows, Mac, Linux, right? Okay, good. Every operating system has JVM. Okay, we got one point, right? Every operating system has JVM. Every operating system has JVM. Now let me just make it a bit more clear by giving you an example of WhatsApp. Every operating system has WhatsApp, right? WhatsApp. Even Android systems will have WhatsApp, right? Correct, which will have WhatsApp. But do you think in Android we have what? A WhatsApp.apk. Do you think this apk file will run here in Windows? No, right? It will not run. If your WhatsApp is of Android, will it run on iPhone? No, it will not run. Cool. Why? Because everyone is having their own JVM. Everyone is having their own JVM. So JVM is platform dependent. Okay, it is dependent on the platform where you are using. But tell me one thing. If you are writing hi from an Android phone, if you are writing hi from an Android phone and you are sending it to a iPhone person, does the hi change? No, the hi is still hi, right? If your H is capital here, he will also receive the message as H capital, I is small, he will receive also the I is small. Correct? So what this means is, if you have the ability to have an intermediate code, okay, this happens why? Because there is an intermediate code which is being interpreted by the JVM, okay. The code can be different, but now you see what will happen. So what does Java do? Java does not directly convert the code into machine language. What it does is, Java will convert your high level language code to byte code. This byte code can be ran on JVM, so it can be a byte code. Now you tell me, if the code is same, if the code is same, obviously the output will be same. Output at in every environment will be same. Correct? Because the code is same. Java converted it into a bytecode, okay, and this bytecode can be ran by any JVM, can be ran by any JVM. Since it is the same code, of course the output in all the JVMs will be same. All the JVMs will be same. All the JVMs will be same. That is why Java is platform independent, because Java does not directly convert the code to a machine language. It converts it into bytecode, and bytecode can be ran by the JVM. And JVM, this guy is present in all operating systems, and JVM is present in all operating systems. Without JVM, there is no operating system. Understood? Which means if you created a code in Windows, you can compile and run it into your MacBook as well. Okay, so this is how Java becomes platform independent. Which there is a tagline of Java: write once, run anywhere. Okay, then there were a few things which I already explained. ML. What was ML? ML was machine language binary 0 1. What was bytecode? Bytecode is an intermediate platform independent code produced by the compiler. Compiler and interpreter you would have heard, right? For we know it is getting computed by the compiler. Okay, why then why is Java portable? So for this very same reason, it is portable. Also we can say it can go to other systems without any changes. It can be ran on different systems without any changes. Okay, once the code is written, it can be ran on different systems without any changes. Why? Because we just now understood, because of this bytecode thing. Okay, because of this intermediate bytecode thing. Okay, and then why is Java robust? Robust because anything is robust means if it is having some issues, it can handle those issues. Robust thing is something is robust means suppose it is a very robust house, so which means any andhi tufan whatever comes here, it will be stopped, right? Any storm or flood, anything, it can withstand that things, right? So that is why it is robust. Why? Because it has exceptional handling, auto management of memory, compile and runtime checks. Okay, for now you just have to understand these points, but we will be diving deep into each and every word later in the syllabus as well. Are we clear here? Are we clear here? Why was what we wanted to say? JVM is Java does not directly convert your code to the machine language, right? It has its own binary code. Okay, just a second. Okay, now what we want to go? We want to know why is Java secure. So Java is secure because in Java, the directly memory access is never given. Java codes will run in JVM, you know. It will run via JVM. Okay, it will run via JVM. Okay, it will run via JVM. So every Java virtual machine has certain checks, okay, to verify the bytecode that has been compiled by the compiler. You wrote a code, suppose you wrote a malicious code which is having some hacking stuff. Suppose you wrote some malicious code which can play with the security of the system. But since you do not have access to run the code, you do not run the code, you can only trigger the running of code. Once you trigger the running of code, what happens? Java will convert it into bytecode. This bytecode will be then interpreted by the JVM. Line by line, it will be checked line by line. If there is any issue found, the code will not run. If there is any issue found, the code will never run, which means it is secure. And then why is Java is case sensitive? That is the feature of Java, means it will distinguish between uppercase and lowercase. Uppercase means capital letter, small case means lower letter. If you write capital A double P L E apple and if you write small a double P L E apple, these both are not equal. These both are two different things for Java. Understood? Cool. So this is the whole gist is this, very, very important. Cool. So we were talking about JVM stuff like that. Not too many times. So here is the exact thing what we are talking about. JDK, JRE, JVM. Okay. So what is the meaning of JDK? What is the meaning of JRE? And what is the meaning of JVM? JDK means Java Development Kit. See, the word itself says Java Development Kit, which means without this you cannot write and run Java programs. So this is used to write and run the Java programs. JDK is used to write and run the Java programs. So it is used to write. Okay, I told it is used to write, and I told it is used to run also. So if it is used to run, so obviously inside JDK, JVM will be present. You are trying to understand me, right? If it is able to run, which means inside JDK, JVM will be also present. And before running, you know, every code is getting compiled. It has to get compiled for any errors. And who does this compilation thing? Compiler, Java C. Java C. That is why in JDK you will have Java C also, you will have JVM also, and then the related libraries. Everyone knows that there is libraries, everyone knows that there is Java C, but many people forget that there is JVM. Okay. For school students, if you are listening this ICSE board ones, you do not need to go deep into this. Okay, just if you are really interested, you can understand, so that you get a full theoretical knowledge like how everything works. Okay. So libraries, what is libraries? Libraries are, suppose you want to know something about bio, you have some 100 books of bio, so you will go to your library and you will pick up each book for each topic, right? So similarly Java has its own library. To there you write a lot of text, right? In Java, to understand that text, Java has java.text library. So in that the Java can understand all the text that you have written. Similarly, to perform mathematical functions, mathematical calculations, sine, cos, math.pow, power, square root, these all things are defined where? If you write sqrt, how will Java know that what is the meaning of sqrt? You know that the meaning of sqrt is to take square root. So 196 square root will be 14. No, it will be 14.0. Don't make a mistake here. Okay, we'll come back to this later. So those things are declared in java.math. Okay, then you have java.io for input output, to take the input from the user, scanner class and those class are there, right? So you need to have this library java.io. Okay, similarly there is one point here, just a second. Okay, so these are your things, right? And then you have something very, very important, that is java.lang. Okay, this is java.lang. In MCQ question it can be asked. Okay, it is what can I write here? I can write something like, it is by default, it is called by default. Okay, by default. Okay, it is called by default, java.lang is called by default. Okay, so you have to keep this in mind as an MCQ question. Cool. So we understood what is the components of JDK and why they are there. Java C, JVM, libraries, right? Then we have, once you have this, then you have JRE, Java Runtime Environment. Java Runtime Environment, which will be used to run the Java programs, And your JRE will have JVM plus libraries. This will also have libraries. Why? Because it is going to run the program, so it also needs to have the knowledge of each and everything. Okay, and then you have JVM, Java Virtual Machine. So every operating system, operating system is just what your it is a machine, right? It is their machine which is having a lot of semiconductors, stuffs like that. In each this machine there is one virtual machine of Java installed everywhere. Okay, what it does, it executes the bytecode, it executes the intermediate bytecode. Time and again I am saying intermediate. I'll just edit here and put that intermediate word. Okay, so that in the PDF you can see that what it does, it converts the bytecode to machine code. Okay, JVM is platform dependent. See, JVM is platform dependent. Okay, every platform will have its own JVM, which means it is platform dependent. Iska JVM you cannot run here, iska JVM you cannot run here, iska WhatsApp you cannot run here, iska WhatsApp you cannot run here. But Java is platform independent. Why? Because of JVM. You see the contrast. You understand this, right? Why is Java platform independent? Because of JVM. Because Java will produce the same bytecode, so you can run the same code everywhere. If you write hi there, if you message this from Android to your iPhone friend, it will still go as hi there, right? Just the things that are just the platform is different. Okay, cool. So once we understood this, we can now, what we can do, we can now move to compiler and interpreter. So for compiler interpreter, what I will tell you, compile, pile, it is pile, you know, pile of wood. Pile of wood means there are a lot of wood and this wood is roped in with a bandage. So all at once, all the wood at once. So compiler. And interpreter means line by line. Interpreter means suppose PM Narendra Modi ji, he goes to some outside country like South Africa and he is giving a speech there. Yeah, okay, so that his speech line, one line he will speak and that line will be translated by a translator line by line in the native language. So that is why compiler and interpreter. So what does compiler do? It executes the whole code. It will execute the whole code at once. What will interpreter do? It will execute the whole code line by line. It will execute the whole code line by line. What is, so since it executes the whole code at once, so it will be faster. Since it executes the whole code line by line, so it will be slower. So this is the advantage of this, this is the disadvantage of this, and due to this advantage there is this disadvantage, and due to this disadvantage there is this advantage. What is that? Debugging is difficult. Okay, debugging means what? Bug means errors in the program. Then debug means what? The act of removing those bugs is called debugging. Okay, so since it will compile the whole code at once, all at one go, that is why all the errors will come at once, and then you will have to manually find all the errors in the program. In real world you have thousand lines of code, right? So debugging will be difficult, but here debugging is easier. Why? Because line by line it executes, and suppose in the 505th line it gets an error, so it will stop there, and then you can easily see the error and you can fix it. That is why debugging is easier, which that is why C and C++ they use compilers. Okay, they use compiler. That is why these are faster. And Python and JavaScript they use interpreter. But you see there is no example of Java till now. So what does Java use? Java is very smart. Java uses both compiled and interpreted language. Java is a both compiled and interpreted language. Very important question. Why is Java both compiled and interpreted language? So we know that the source code that you write in high level language is first converted into an intermediate bytecode. So now instead of converted word, here it comes the compiler. Who converts this? The compiler converts it. So our high level language, the source code is compiled by the compiler into an intermediate bytecode. It is compiled by the compiler into an intermediate bytecode. This bytecode is then interpreted by the JVM. It is then interpreted by the JVM for execution. That is why see here in this process, in this step, the compiler is getting used, and in this step the interpreter is getting used, which means Java is both compiled and interpreted language. Okay, cool. Now we are moving forward ahead. We talked about bugs, right? We talked about bugs, errors, right? So now we have to also go deep into these errors. What are these errors? So there are technically three types of errors: syntax error, logical error, runtime error. What is a syntax error? Syntax error is the error in the code syntax. So suppose you write int a equals to 5 plus 2 and then you put a comma. You know every code in Java in the line it will come a semicolon, but you wrote a comma by mistake. So this is syntax error. Understood? So this is syntax error, correct? So in this way you can have a syntax error. Cool. What is logical error? Logical error means there is, and this syntax error is caught by the compiler. Okay, whatever before, while compiling the program, the compiler will check and highlight this error, that here there is an error. Okay, there semicolon is missing. Okay, logical error in logic of the code, which means suppose I told you to add two numbers, that you have to add two numbers, but while writing the code you did minus two numbers. Will the Java be able to catch this error? No, of course it cannot catch these errors, because this is your error in your logic. It will give you wanted the output as 5, but here it will give you the output as -1. Why? Because your logic was wrong. You had made a mistake. The human mistake it is. Okay, it is a mistake on the logical end. So this cannot be caught by the compiler. Then you have runtime error. So runtimes means during the execution of the program. Runtime means during the execution of the program. Suppose you are getting something called to divide it by 0. Okay, so that time the runtime error will come, And very important point, it is caught by the JVM, not compiler. In exam, in the speed we write it, but now you have the clarity that JVM is the guy who will execute the program in the end, right? So who will catch? Who will catch? JVM will only catch this error. So this error is actually caught by the runtime error is actually caught by the JVM. Because I told you now, why is Java both compiler interpreter? Compiler ka kaam is done till here. Compiler has done its work till here. After that, the code has to be ran by the JVM. So this point, so interpreter. Okay, so this execute, so the runtime error is caught by the JVM, and this syntax error is caught by the compiler. Cool, understood? Great. Now we also wanted to know each and every meaning of each and every word, but if I explain it now, none of you will understand because we have not gone to the programming part. Okay, so we'll skip this for now. There is also a video, I have added it. If you want to view it now itself, you can see it. But I suggest once we start getting acquainted with a lot of theory and coding language or coding into Java, we can go into that. Okay.